Natural sounds safe. Synthetic sounds artificial. But when it comes to peptides, that distinction can be seriously misleading. Because here's the truth. Your body can't tell the difference if the sequence is identical. So what does natural versus synthetic peptides actually mean? And why does this confusion lead so many people in the wrong direction? Let's break it down. What are peptides? Visuals. Amino acids linking right arrow peptide chains forming first, quick foundation. Peptides are short chains of amino acids. Think of them as mini proteins that act as signals in the body. They tell your system what to do. Release hormones, repair tissue, regulate metabolism, communicate between cells, examples you already have in your body. Insulin growth hormone signaling, peptides, oxytocin, these aren't foreign substances. They're part of your natural biology. What does natural actually mean? Visuals. Nature imagery, right arrow cells producing peptides. When people say natural peptides, they usually mean one of three things. 1. Produced inside the body, these are peptides your body makes on its own. 2. Extracted from natural sources, some peptides can be isolated from animals, plants, or bacteria. 3. Marketed as natural for appeal, this is where things get tricky, because the label doesn't always reflect origin or quality. Here's the key point. Natural describes where something comes from, not how it behaves. A peptide doesn't become safer, stronger, or more effective just because it's labeled natural. What does synthetic really mean? Visuals. Lab synthesis animation, right arrow step-by-step chain assembly. Synthetic peptides are made in a lab, but that doesn't mean they're unnatural in function. They're built using a process called solid-phase peptide synthesis. Scientists assemble amino acids one by one, in the exact same order as the original sequence found in nature. So if a synthetic peptide matches a natural one perfectly, it behaves the same way in the body. Same structure, same function, same receptor interaction. The body doesn't check where it came from, it only recognizes the molecular structure. The big myth. Natural equals better visuals, split screen. Natural versus synthetic with question marks. Let's address the biggest misconception. Natural is always better. That sounds logical, but it's not scientifically accurate. Here's why. Some natural peptides are unstable, some break down too quickly, some are hard to extract in pure form. Meanwhile, synthetic versions can be more stable, more consistent, more precisely manufactured. In fact, many peptides used in modern medicine are lab-made copies of natural ones, because synthetic production allows exact control over purity, reliable dosing, consistency, scalable production. So the question isn't natural versus synthetic. The real question is the peptide accurate, pure, and well characterized? Identical V's modified peptides visuals. Highlight sequence changes, right arrow small modifications glowing. Now here's where things get more advanced. Not all synthetic peptides are identical copies. Some are modified versions of natural peptides. These changes are intentional and done to improve performance. For example, extending half-life, increasing stability, improving receptor binding, slowing breakdown in the body. These modified peptides are sometimes called analogs. They're inspired by nature, but optimized. So now we have three categories. Natural peptides, made in the body, synthetic identical copies, synthetic modified versions, and each serves a different purpose. Quality matters more than origin visuals. Lab testing, right arrow HPLC graph, right arrow mass spec visuals. This is the part most people overlook. What really matters is quality control, not whether something is natural or synthetic. Key factors include purity, how much of the peptide is actually correct. Identity, is it the right sequence? Contaminants, what else is in it? Stability, does it degrade? Even something labeled natural can be impure, degraded, contaminated, and a well-made synthetic peptide can be extremely precise, highly pure, consistently reliable. This is why manufacturing standards and testing methods, like HPLC and mass spectrometry, are critical. Where confusion goes wrong. Visuals. Social media clips, right arrow marketing claims, right arrow warning icons. Here's where people get misled. Marketing often uses natural as a shortcut for safer, cleaner, more effective, but those claims don't automatically hold up. On the other side, synthetic gets framed as artificial, risky, inferior, which also isn't true. The reality is much simpler and more honest. A peptide structure and quality determine how it behaves, not the label. Conclusion. Visuals. Clean summary graphics, so let's wrap it up. Natural means it originates from biology. Synthetic means it's made in a lab if the sequence is identical. The body treats them the same. Modified peptides are designed to improve function and, most importantly, quality matters more than origin. If you remember one thing, it's this: the body responds to structure, not marketing labels. If you found this useful, subscribe for more deep dives into peptide science without the hype.